The Girder grid expansion joint is the classic system for watertight expansion joints with an expansion range from 80 to 640 mm. The support bars of the Girder grid expansion joint are parallel to the primary movement axis, while the beams are arranged parallel to the edges of the bridge structure. The edge beams are rigidly anchored in the structure. In order to avoid material fatigue, traffic loads are transmitted to the abutting reinforced concrete construction via anchor plates. The support boxes, which provide the support bars with room to move, have welded stud shear connectors for permanent connection to the abutting concrete. With steel construction bridges, the edge structure is placed on consoles or support girders parallel to the end cross girders. Every center beam of the Girder grid expansion joint is rigidly welded to the support bars allocated to it. Thus, a girder grid which can be moved within itself is created. Springs, positioned between the support bars, control the equal separation of the center beams from one another in relation to the total width of the joint gap. In addition to the conventional movements along the roadway axis, secondary movements can also occur. For example, rotations due to uneven temperatures, or translations from abutment movements and elasticity of the bearings. The Girder grid expansion joint is capable of accommodating such movement to a certain degree. The control springs, positioned between the support bars, or between a support bar and the side wall of the support box, are made of primarily cellular polyurethane, with high damping characteristics, and ensure a uniform distribution of total movement to the entire joint gap. The high level of permissible deformation, up to 80% compression deformation in relation to the uncompressed initial length, makes it possible to build elements with even higher permissible spring movement ranges and comparatively small dimensions. The material's inherent damping also causes vibration damping and shock damping of the components under dynamic stress. The arrangement of the backing studs for fastening the control springs to the support bars results in a compression of the springs as the gap becomes wider. The springs are compressed in any open position, while the preformation stress is least when the gap is the smallest. This control system offers a clear advantage in terms of adaptability to manufacturing tolerances, minimal failure rate, high durability, resistance to movement stress, noise suppression, and the possibility of enlarging individual gaps for repairs. The support bars of the Girder grid expansion joint receive elastic and shock-absorbing support in the direction of movement of the structure from bearing elements, the sliding bearings positioned between the support bars and the support box bottom, and the sliding springs positioned between the support bar and the support box lid. Pre-stressing the sliding springs keeps the bearing from raising the support bar and balances out manufacturing tolerances. For evening out the inevitable differences in height between the edges of the structure due to changes in the support bar gradient, the sliding bearing is rotationally pliable. The horizontal loads from the vehicle wheel rolling over the joint are transmitted by the elastic and torsionally stiff center beams and passed on to the support bars. From there, they are transmitted via the bearing elements and control springs to the joint edges.